Have you ever wondered why things have mass? Why does an electron weigh something, while light has no mass at all? The answer lies in one of the greatest discoveries of modern physics, the Higgs boson, also called the God particle. Hi, it's Beacon Bin Science, your favorite science show, and in this video, we're diving deep into the science behind mass, the mysterious Higgs field, and how it changed our understanding of the universe forever. Back in the 1960s, scientists were building what we now call the Standard Model of particle physics. It explains how all fundamental particles interact, using three of the four fundamental forces, the electromagnetic, weak, and strong forces. Everything seemed to work well in the equations, but there was one huge problem. The theory predicted that particles like the W and Z bosons should have no mass at all, just like the photon. But experiments showed that the W and Z bosons are very heavy. Now, before understanding about Higgs boson, let's first understand what is Z and W boson. They are force-carrying particles responsible for the weak nuclear force, which governs radioactive decay. The W boson has a mass of about 80.4 giga-electronvolt per speed of light squared. The Z boson is even heavier at about 91.2 giga-electronvolt per speed of light squared. But here's the problem. The basic equations of the Standard Model use gauge symmetry, which only works if these particles have zero mass. The electroequivalent, simplified. In the unbroken symmetry phase, the masses come out as O. Mass of W boson equals 0. The mass of Z boson equals 0, and also the mass of photon equals 0. But as we know that W and Z bosons have mass, so clearly, something was missing in the theory, and that missing piece was the Higgs field. What is the Higgs field? The Higgs field is an invisible energy field that exists everywhere in the universe. You can't see it, but it's always there, even in a perfect vacuum. Imagine the Higgs field as invisible honey spread throughout the universe. As particles move through it, they get stuck or slowed down. This slowing down is what we perceive as mass. Some particles, like the photon, pass through the Higgs field without any interaction, so they remain massless. But others, like the W and Z bosons, interact strongly with the Higgs field and gain a lot of mass. So the Higgs field is what gives W and Z bosons their mass, while preserving the symmetry of the Standard Model. Let's understand what is the Higgs boson in detail. Now comes the big question. What is the Higgs boson itself? Think of the Higgs field like the surface of a lake. When you toss a stone into the lake, ripples appear. Those ripples are the Higgs boson, tiny disturbances or vibrations in the Higgs field. The Higgs boson is a quantum particle that proves the Higgs field exists. It is a scalar boson with no electric charge, no spin, a mass of about 125 giga-electronvolt per square of speed of light. It decays very quickly, within 10 to the power of -22 seconds, into other particles like photons, W bosons, or bottom quarks. On July 4, 2012, scientists at CERN finally announced the discovery of the Higgs boson, using the Large Hadron Collider, LHC. Two experiments, ATLAS and CMS, observed a particle with a mass around 125 giga-electronvolt. This confirmed the existence of the Higgs field and completed the Standard Model. It was a historic moment. Peter Higgs, who had predicted this particle back in 1964, was in tears. Without the Higgs field, the universe would be a chaotic place. Particles would have no mass. There would be no atoms, no stars, no people. The discovery also opens doors to new physics, supersymmetry, dark matter, and possibly extra dimensions. The Higgs boson may have appeared for just a trillionth of a second, but its existence changed science forever. Thanks for watching. If you learned something new, hit like, share this with your friends, and don't forget to subscribe. And tell me in the comments, which particle should we explore next?